all the way from the physical sciences area, please help me welcome Anne Fortman.
How would you figure out what the universe is made of? You might want to use the so-called Large Hadron Collider, a circular machine 17 miles around, located near Geneva, Switzerland. It smashes protons together, and in the mess of particles flying out, there might be undiscovered particles that could tell us something new about the universe. We can't let them get away. That's why international teams of physicists build machines called detectors around the collision point. You can think of detectors like cameras, recording traces of particles so we can study them. The collider is about to get a powerful upgrade, and the detectors we have now will be completely overwhelmed. So we need to build new detectors. One team, called Atlas, is building a detector made of thousands of square silicon sensors like these. Each square is made up of over 5,000 tiny strips, and each strip can detect particles. Without this detector, we cannot effectively study particles at the new collider. This detector is currently breaking, catastrophically. The problem has to do with temperature. We need to run this detector cold, around minus 30 degrees Fahrenheit. When materials get cold, they contract, and some contract more than others. The sensor is built like a sandwich of materials, with electronics, mainly copper, glued down to silicon. Here's the catch. Copper contracts more than silicon when cold. The force of the copper contracting pulls on the silicon through the stiff glue between them. The silicon bends and bends until it cracks. This is really bad. When the silicon cracks, the entire sensor is done for, and we miss any particles passing through. So I am working with a global task force to redesign this detector. We've tried remaking the electronics with less copper, but the silicon still cracked. We tried spacing them out more to disperse the stress. Still cracked. Then we added more support underneath the silicon, and cracked. And now we have one potential solution left. The idea is to place a new layer of soft glue between the copper and the stiff glue, like adding mayo to this sandwich. Now, when the copper contracts, the force should be absorbed by the squishy glue underneath and won't bend the silicon. We've started building detector pieces with the new soft glue, and we've tested them colder than ever, minus 95 degrees. That's colder than the South Pole in winter. And we found not a single crack. Now we have thousands of pieces left to build, but this is a successful proof of concept. At long last, we have a promising solution to the cracking problem. So this detector will be ready to track down new particles and answer the big questions about our universe.